Okay, this is like number 47 on page 92. Basically, you have two binomials and you're multiplying them, so you're going to end up having to do FOIL. I find it easier because this has a fraction to make this have a fraction and then multiply it and combine like terms. But there's really two different ways to do it, so I could show you two ways to do it. So I make a 1 on the bottom here. Then multiply this by y over y so that they both have the same denominator. So I get y squared over y minus 2 over y. Not doing anything with this last part yet. Then I can make this one fraction by writing it y squared minus 2 all over y times y plus 3. I'm going to put that over 1. Do you follow what I did there? Now, if I multiply it, on the bottom, y times 1 is y. Hope I can squeeze this in here. So I'm going to do FOIL. So y squared times y to the third. Y squared times 3 plus 3y minus 2 times y minus 2y minus 2 times 3 minus 6. And then you can simplify this by dividing each part by y. So y cubed over y, y squared. 3y over y, is that supposed to be 3y squared? It is. Sorry about that little error. So 3y squared over y is 3y. 2y over y is minus 2. And then minus 6 over y is the final part. And that's the answer. Last year in Algebra 2, sometimes we would just leave the answer like this. This textbook's a little bit different. So there's one way to do it. Another way is you could just do FOIL right off the bat, even though there's a fraction there. Sometimes I think that's a little bit messy, but watch what happens. So y times y squared, y times 3, 3y. Now I'm going to do minus 2 over y times y. That becomes minus 2. Minus 2 over y times 3 is minus 6 over y. And look, y squared plus 3y minus 2 minus 6 over y. Get the same answer both ways. I'm not fussy about what way you do it, so good luck and keep working on that summer assignment. All right, here's one like 73. Basically, you have a double complex fraction here. I mean, here's the main fraction bar, and here's the bottom, and here's the top. But the top of the fraction is also got a fraction in it. So you need to do common denominators for each part, and then you know that when you do the top divided by the bottom, it becomes the top times the reciprocal of the bottom. So all of that stuff comes into play here. So the first thing I'm going to do is just work with this bottom here. If I want to get these two parts together as one unit, I need to make this 1 some fraction that has the same denominator as that x. Do you know what I could make it? I could make that x over x. That's the same thing as 1, right? Okay, so here we go. 4y, I'm not going to touch that, over y squared over x minus x over x. Okay? And then if I want to combine these two parts to get them to be one fraction in the bottom, what would be the common denominator for these two? 2x. So I could make this 2x over 2x. That's the same thing as 1, right? Yeah, you know that. Okay. So 3y over 2x minus 2x over 2x. So there's a lot going on. All right. So now what I'm going to do is I'm going to do the bottom first because it looks a little easier. I'm going to write that as one fraction. 3y minus 2x all over 2x. 3y minus 2x all over 2x. So that's the bottom of the fraction. I'm going to put it in a bracket here because that's one sort of blob. Now I still have to work with this. So can I make this part of the bottom one fraction? Sure, y squared minus x all over x. So we're going to keep the 4y way up top, and then y squared minus x all over x. that's the top of the fraction. Now, here's where it really gets tricky. And you got to be careful. I can do, it's 4y divided, fraction bar means divided by, so it's 4y divided by this. So instead of writing divided by, I'm going to write 4y times, and how am I going to change it? Flip it over, right, x and y squared minus x. That's called using the reciprocal. All right, so this is the top of the fraction. And I end up with 4xy over y squared minus x. We'll put that in a bracket. That's what the top of the fraction simplifies to. Let's put our fraction bar. And now I have the bottom of the fraction, 3y minus 2x all over 2x. I'm going to put that in a bracket just so that's a little easier to see. Hey, can I reduce that 2x with that 2x? Oh, I hope you said no. That was a trick question. Can I reduce that x with that? Or that y with that? No, because this plus or minus sign's there. So be careful. Don't re-reduce something there. All right, so I have this fraction divided by this fraction. What's the rule? When you divide fractions, you take your top, which is 4xy over y squared minus x, and change the sign to times. It's divided by this, so divided by this means what should I do? Use its reciprocal. Quick fix, you guys always say, flip it over. All right, so that's that. Let's put parentheses there, because those are little blobs. All right, and basically, I am done. Let me get a little more room here. So the final answer is 8x squared y all over those two things, y squared minus x, 3y minus 2x. Yucky looking answer, but that's it. Now, if I had a separate variable out here, I might be able to do some reducing, but this particular one does not, and I think the one that you're trying to, number 73, doesn't either. So, good luck with those.